I want to explain to you a little bit more as about the SSE, right? You know, before when we discussed this SSTR, which was the double summation, I and J, it was the between. So xi bar minus x bar square. But we modified because in the difference, it does not have the J index. So we modified, it will be the summation I and I xi bar minus x bar square, right? And today we have a SSE, and I gave you is another double summation I and J. Is actually it was inside is within, so each observation minus each sample inside from each is a square. So please focus on the summation of J. It's actually the J from 1 to Ni. So let me think about the sample I, the ith one. It's absolutely before, at the beginning, we have a sample 1, and the later one, the last one will be the sample K. But please focus on the in the middle of the sample I. Then we have I1, the very first case in the sample I, xi2, the second case in the sample I, and the last one will be I and Ni, because we have Ni sample in each sample, okay? So just to focus on the sample I. Let me take the variance. It's S squared. You know the notation? The notation of the variance was the S squared variance. But it is the variance from the sample I. So let me plug the index of I. Because what I mean, we are going to take the S1 square as another inside variance from sample number 1. And even we can take the xk square from the sample k. So from the sample I, yeah, we are going to take the si square, the variance from the sample I. You know, actually the variance has the form xi minus x bar. I don't have to write here. Okay, just it's a basically the variance was xi minus x bar square summation divided by n minus 1. Remember the formula is actually 5 steps to get the variance. But now it is a variance in sample I. So I have to use is another index because the I for the sample index and J here is absolutely, we are going to take the sum using the J from 1 to Ni in the sample I, and minus the sample mean from the sample I. So it must be xi bar. It is a sample mean from the sample I. And now we divide it by Ni, the sample size, in the sample I minus 1. So be careful. Now the index of j is each observation. In sample I, the index of I now is for the sample, right? So be careful. I switch the meaning of the index. Okay, now let me multiply ni minus 1 here because I want to cancel out. Then times ni minus 1 here. And now what? The right-hand side will be summation j from 1 to ni xij minus xi square will be simply ni minus 1 si square. Now the right-hand side, it's just simply sum of square. It will be this. So far, so good. Please try one more time by yourself, right? It's carefully using the notations. Yeah, please try it one more time. And now, please compare this one, the summation of the inside of the SSE, and this one. It's a single summation for J, single summation for J, 1 to Ni, 1 to Ni, exactly same. So now I can replace with the left-hand side. What I mean, now I can modify, it's like this way, like this one. It will be the single summation I is absolutely the index of I from 1 to k, and now it's a ni minus 1 si squared. So always we have two formulas. One is the double summation, and the modified one is a single summation with the I and the modification like this way. Now I can interpret another way. What is the SSE? Simply it is a summation of each variance. You know, that is the sample variance. So SSE is simply summation of the all variances, all sample variances. And actually it is the inside the variations. Okay, next time we are going to discuss how can we use the two mean squares. So we have I think yes, we have two variances. So next week, yeah, we are going to discuss how can we analyze the two variances. For what? Comparing the population means.